recording and sharing the screen, and we want this one. So I'm looking homework 32, I think is, I don't even remember what was on homework. Oh, I think that was on simplifying. Homework 33 and 34 are on your operations with rational expressions. Homework 35 and 36 are what we're looking at today, which are radicals. Problem set 5 is due on the 10th, which is a week from today. That test is on the 10th, a week from today. I am thinking that the class before, which will be the 8th, we're just going to review, go over the problem set. The final is on the 17th, which is the last day of class. And so on the 15th, we'll do the same thing, the practice final. Now I'm going to leave a little bit of what happens on the 10th and the 17th up to you folks. Well, actually now, well, yeah, on the 10th, the test will be due. Oh, actually, I've said got it open from the 10th to the 13th. If you want to meet in class and go over it one more time, that's fine. If you want to instead use class time on your own to work on it, I'm not going to necessarily have anything scheduled to do on the 10th, and the same with the 17th. I'll be here in front of the computer, probably grading other things, but having Zoom on, and if you want to come in and go over anything on that day too, before you attempt your final, I'm fine. You know, that those 2 days I'm going to leave as flexible and for you is to make use of on a drop-in basis. How's that sound?
Sounds fine.
Sounds good.
Okay.
So when, can I ask a quick, so when it says the final is 8 a.m. to 8 p.m., that means we still have whatever, the 120 minutes to do it, but we can do it anytime in between that time.
Right. Right. Just like over here, this test will be open from the 10th to the 13th. So probably early in the morning on the 10th till 11:59 on the 13th.
Okay.
It'll be a 75-minute test, although I don't think you'll need that much time. But you can take it any point in time between those days. So the final you can take, it'll be 100, they have 150 minutes for it. And you can take it at any point in time in between those, but an hour and a half. You probably want to start it by 5:30 right in the afternoon so that your 2.5 hours takes you till 8.
Okay.
Yep. And if there's any technical problems while you're taking a test, send me an email right away and I will try to fix it. I think I've got both tests set up so that if you have a technical problem and you get bumped out of the test, that you can go back in if the time clock will still be running and all of that. But I don't think you need my permission to re-enter it. But again, you can only take it one time. Okay. And again, with both of those, you put your answers in my labs, but I'm not, the grade is based on the work that you submit in Blackboard. So for both these, the test is in my math lab, but you have to submit the work in Blackboard. And there'll be a drop box in Blackboard for each. And the grade will not count if I do not see work. I mean, okay.
Yep.
Okay.
So let's get started with today. First thing I want to ask is, does anybody want to look at anything at all? Any problems from any of the homework? Does anybody want to look at anything in my math lab?
I haven't finished them all to say that I
Okay,
need
how
help with any.
is it going? Okay.
Yeah, yeah. Mhm.
Good, good, good. And Lynette, how about you?
Yeah, I'm doing okay.
You're doing
I'm current with my homework. I haven't done homework 33 and 34 yet. That's due next Tuesday.
okay.
Okay, right now.
All right, if you can get to them before Tuesday, that would be good. Did you ladies want to go over any of those problems, or shall we leave that going over those till next Tuesday?
It's up to you, whatever you'd like to fit in or not fit in. It's up to you.
It's,
Or-
let's look at the radicals, and then if there's time after we finish looking at the new content, the radicals, we'll go back and do some of the rational expression homework together. How does that sound?
Mhm.
Okay. So, let's go over here. Wow, I scribbled all over that page, but does the scribbling make sense?
Yep.
All right, then let me add a page. And today we're going to look at radicals. The symbol for radical looks like this. Hopefully that looks familiar to everybody. Called the square root.
Does it mean square root?
And so
Okay.
if I say that A is equal to the square root of B, what that means is that B is equal to A squared. It's the opposite of the square root. So it's the opposite or inverse of squaring a number. Before we look at what it means, let's look at a little bit of the terminology. If I have A is equal to the square root of B, A is called the root, B is called the radicand. So the radicand is what's underneath the symbol. The symbol itself would be the radical. So I'm going to look at a pretty straightforward.
100% that we need masculine.
I'm going to look at a pretty straightforward example. I'm thinking it's probably something that both of you can answer for me. If I ask for the square root of 4, what is it? What number squared gives me 4?
2.
2. So the square root of 4 is 2. Now, when I look at the square root of 4, what most people think of is 2, because 2 squared equals 4. But can't it also be negative 2? Because when I square negative 2, I also get positive 4. So the square root of 2, the square root of 4 technically can either be positive 2 or negative 2. So we're going to say that every real number, take that back, I lied, every positive real number has 2 square roots. One positive and one negative. So that kind of leaves it a little bit ambiguous if I can get 2 possible answers. And so when we look at the square root of 4, we're going to mean 2. And in general, if I have the square root of, let me put the variables in the same place I did before, the square root of B equals A. If it's written like that, we're looking at the principal or positive root. So if there's just the square root symbol written, it usually means just the positive root. Instead, if I have the negative sign out in front, that's when I want the negative root. So here, the principal root of 4 is 2. The negative square root of 4 is negative 2. And then just to make life fun, if we want to consider both roots, consider both the positive and negative, we're going to write this other symbol. We're going to put, it's like a plus sign over a minus sign. Plus or minus the root of b is plus or minus a, or positive a, or negative a. We want to include both. So if I had plus or minus the square root of 4, the answer is plus or minus 2, which could be positive 2, and then also negative 2. And I have 2 possible solutions. So if I, let's say the square root of 16, what number times itself is 16?
4.
4, beautiful. Instead, if I want the negative square root of 16, it would be negative 4. If I want the square root of 49, what number times itself would give me 49? 7. And then if I wanted the negative square root of 49, it would be the negative 7. But is everybody okay if I turn the page? What if I ask for the square root of not 4, but negative 4? Is there some number that I can square and get a negative answer? Well, if I took negative 2 and squared it, I get positive 4. If I take 2 and square it, I get positive 4. And that idea that whenever you multiply a sign by the same sign, the result is positive, we're going to say that it does not exist yet. Next semester, when you're a little bit older and a little bit wiser, if you're taking Math 110, you'll find that there's a way in which we can take the square roots of negative numbers, but they're no longer real. And if they're not real, instead of calling them fake, we call them imaginary. But that's beyond the scope of this class. We're going to say, in general, you cannot take the square root or, for that matter, any even root and we'll get to what that means in a minute, of a negative number. It's not real. Let's look at a couple more examples. What would the square root of 0 be? What number squared gives me 0.
I guess 0.
The square root of 0 is 0. Perfect. Now, what if I ask for something like the square root of 25 over 81? Is there something I can square to get 25 over 81?
5 over 9.
5 over 9. And so that's going to be 5/9. And we're going to take that idea and generalize it to say that the square root of a quotient, the square root of a fraction, a over b, is equal to the square root of the numerator over the square root of the denominator. So what if I ask for something like the square root of 18 over 50? Ike's 18 is not a perfect square, nor is 50. But I'm going to ask you, can you simplify the fraction 18 over 50? Is there any number that goes into both 18 and 50?
2.
And so when I divide 18 by 2, I get 9. And when I divide 50 by 2, I get 25. So is it okay to say the square root of 18 over 50 would have to equal the square root of 9/25? Reducing the fraction first. And now we can take the square root of 9. We can take the square root of 25. And so that will leave me with 3/5. So far, so good.
Mhm.
And so those are square roots. We also talk about, can I turn the page to not hurt anybody's feelings? Other roots. Again, we said that if b is equal to a squared, that a is called the square root of b. For other roots, we're going to say that if b is equal to a to the third, then a is the third root of b. And when I look at that third root, it's called the cube root, because I'm asking what number do I cube or raise to the third power to get there. And so how would that work? If I asked for the cube root of 8, I'm saying, is there a number I can multiply by itself 3 times to get 8? Let's see, 1 times 1 times 1 is 1. How about 2 times 2 times 2? 2 times 2 is 4, times 2 is 8. So we'll say that 2 to the third is 8. And so we'll work backwards and say that the cube root of 8 is 2. What if I ask for the cube root of, let's say, 64? Is there a number to the third power that equals 64? And to a certain extent, we're going to try get these by trial and error. We know it's not 2 because 2 to the third is 8. It couldn't be 3 because this is an even number, right? 3 to the third, odd times odd times odd. That would be really odd. What if I were to take 4 to the third? If I take 4 times 4 times 4, what do I get?
64.
46.
64. And so their cube root will be 4. But I digress, and I want to go back to that cube root of 8. Can I take the cube root of -8? Is there a number that I can raise to the third power and get -8? Well, we said that +2 times +2 times +2 is +8. What if I took -2 times -2 times -2? Negative times negative, this product would give me 4. And a positive times the negative would give me -8. And so what happens is I can take an odd root of a negative number. It will just be a negative. And so we've talked about the cube root, but we can generalize, excuse me, and say that if b is equal to a to any power, then we'll say that a is the nth root of b. And again, if n is even, b must be positive. If n is odd, b can be either negative or positive. It probably looks very hypothetical to you. Let's look at some other roots. What if I ask for the fourth root of 81? Can you think of a number that I can multiply by itself 4 times and get 81? See. 2 to the 4th would be 2 times 2 times 2 times 2, which I think gives me 16. 3 to the 4th would be 3 times 3 times 3 times 3. Let's see, that's 9 times 9, or 81. So the fourth root of 81 is 3. And I have to apologize. I just looked up because the sun's in my eyes and realized that we didn't do a little bit of notation, terminology, pardon me. If I say a is equal to the nth root of b, a is the root, b is still called the radicand, and if there's a little number in the corner telling me what root I want, it's the index. And in general, if I have something like the square root of 100 with no index means I'm looking for the second root, and so that would be 10. So if the index is not written, it's the square root.
So what is the index? Just something to the 4th power?
Or for that matter, I could say, what's the 5th root of 32. And so now I'm saying, is there a number I can raise to the 5th power and get as my answer 32? And so think of a number that I can multiply by itself 5 times and get 32. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And so we'll say that the 5th root of 32 is 2. Instead, let's say I want the 3rd root of 125. Well, then I'm saying, is there a number that I can multiply by itself 3 times to get 125? Any guesses? I'm looking at that, I'm seeing that it ends in 5. Let's try 5. 5 times 5 times 5. 5 times 5 is 25. And then I think 25 times 5. When I think of multiples of 25, I start thinking of quarters. If I have 5 quarters, I have $1.25. So we'll say that the cube root of 125 is indeed 5. And then,
Those are good little tricks when you say things like that. Like that helps me remember things. Just
yeah, you don't
my
do
other
that
3
when you
quarters.
multiply 25s. I always start counting quarters. It's just something I've done since I was a little kid, right?
Yep.
So, and then what's kind of fun too is when we look for roots of variable expressions. And so let's start simple. What would the square root of x squared be? What do I raise to the 2nd power in order to get x squared?
X.
Yeah, so the square root of x squared is x. So if I wanted something like the square root of 4x squared, well, the square root of 4 is 2, and the square root of x squared is x. And so we'll say the square root of 4x squared is 2x. And in general, the square root of a product, the square root of a times b, is equal to the square root of the first factor, a, times the square root of the second factor, b. So if I wanted this something like the square root of 81 x squared y squared, I can apply this idea and take the square root of each factor. And that always, it's so silly. That process always makes me think I was a stay-at-home mom for too many years. It always makes me think of, well, if I have 3 kids and 1 party hat, it'll never work. So I have to give them each their own party hats. And then simplifying, the square root of 81 would be 9. The square root of x squared is x. The square root of y squared is y. But now, what if I want something like the square root of, oh, I'm going to change my variable, a to the 4th? What would I have to square in order to get a to the 4th? Well, here I want to do a little bit of thinking. Do you remember when we said that if we have a raise a power to a power, we multiply the exponents?
Yep,
And-
so it's a squared.
Yeah, wouldn't it have to be a squared? And so if I look for the square root of b to the 10th, what exponent would I multiply by 2 to get b to the 10th?
B to the 5th.
B to the 5th. So then, what if I want the square root of something like 16 a to the 6th b to the 4th? Well, that's the square root of 16 times the square root of a to the 6th times the square root of b to the 4th. And the square root of 16 would be 4. The square root of a to the 6th, well, what would I multiply by 2 to get 6? 3. The square root of b to the 4th, what would I multiply by 2 to get 4? 2. And in general, to find the square root of a variable with an even exponent, we divide the exponent by 2. If I had something crazy like the square root of z to the 100th, well, half of 100 is 50. Does that make sense?
Yep,
So then what if I want something like the cube root of x to the 12th? Well, I'm saying, what would I raise to the 3rd power to get x to the 12th? I'm pretty sure there's going to be an x in here. But what would this exponent be in order to multiply it by 3 and get 12?
the 4th.
4. And so if I'm looking for the nth root of something to the m power, what we're going to do is divide the exponent by whatever the index is. And so let's put a couple of number examples here so that makes a little bit more sense. What if I want the cube root of negative 27 x to the 15th? Well, that'll be the cube root of negative 27 times the cube root of x to the 15th. Now, this is odd, so I'm not going to be scared of that negative there. It just means I'll have a negative answer. What number to the 3rd power gives me 27? Any ideas? Can y'all look at 27 and picture it as 3 times 9?
Yep.
9 is 2 more 3s. So wouldn't 3 3s give me 27? So that part will be -3. And then what would I raise to the third power to get x to the 15? Well, there's going to be an x in there. What would this exponent have to be in order to give me a 15 there?
Five.
Beautiful. And so that would be -3x to the 5th. So far, so good.
Yep.
Then next place we're going, this will be actually the last new thing that we cover this semester, is simplifying a radical. And we guess we'll have to define what it means for a radical to be in simplest form. So we'll say a radical.
So just the answer for that last one was -3x to the 5th, right?
Yep.
Was the 5 times the 3 is 15. Okay, thank you.
I lost it. There it is. Didn't we write that?
You did, I just missed it.
Okay, -3.
All set.
Okay. Let's see. So simplifying a radical, it's just defined that a radical is in simplest form if the first criteria is the one we're going to worry about most today. The radicand can have no perfect square factors. So the radicand has no perfect square factors. So in order to simplify something like that, we're going to use the fact that the square root of a times b is equal to the square root of a times the square root of b. And when I do these problems, I like to have a checklist. I'd like to make a list of perfect squares. Because that list, usually I go through it in my head, but let's write it down so that everybody has it, and see how far we can go with it. Helps with this process. So let's say 1 squared is 1. 2 squared is 4. 3 squared is, help,
9.
9. 4 squared is 16. 5 squared is 25. 6 squared is
36.
36. 7 squared is
49.
8 squared is
64.
9 squared is
81.
10 squared is 100.
100.
Do either of you know 11 squared?
Is it 121?
Beautiful. Do either of you know 12?
143, I'm guessing.
144.
Oh,
That was, I remember having to learn that to my age. They used to, that was a gross, right? A dozen. If you ordered a gross of something in terms of, somewhere that was called a gross. And so we had to note that a dozen is 144. Do either of you know 13 squared? 169. It's a real step there. And so if I want to simplify, let's say the square root of 72. What I want to do is I want to say, do any of these perfect squares go into 72 evenly? So can you recognize any of those numbers going into 72 evenly?
No,
No?
no.
Well, usually if you can find the largest factor, it makes your life easier. So let's look for the largest perfect square factor. And I'm going to give you how that list can help a cheater's method, so to speak. So we're looking for 72. I'm going to say, okay, it can't be 9 because 81 is bigger than 72. So let's look at these numbers. Can I divide 72 by 64 evenly? No. Can I divide 72 by 49 evenly? I don't think so. Can I divide 72 by 36 evenly? Can you guys check with your calculators? Can you divide 72 by 36?
Two.
Yeah. So we can say that 76 is 36 times 2. And so that's the largest square that goes in there. Now, again, each one has to have its own square root. And the square root of 36 is 6. And so 6 radical 2 would be considered my simplest form. And so usually if I can kind of picture this list, or if I have this list, I start with the first number that's smaller and I keep going until I see what can or can't divide it evenly. Some students can look at 72, and can you ladies recognize that as 9 times 8?
Mhm.
But if we do it this way, the square root of 9 times the square root of 8, that would give me 3 square roots of 8. And if I do it this way, I'm not done yet. Because 8 can still be broken down into 4 times 2, yes?
Mhm.
So that would be 3 times the square root of 4 times the square root of 2. So 3 stays, the square root of 4 is 2. And so that leads me to 6 square roots of 2. And it takes me the same place, but it takes a little bit longer if you don't take the biggest perfect square out, if you take a smaller number out.
Could I ask a quick question?
Yep.
On the first one, could it be 2 radical 6 or no? Because you could still,
No,
could you
can't.
reverse those?
Let's rewrite it. When we've got the square root of 72, we're saying that's the square root of 36 times 2. So far, so good.
Mhm.
So then we're going to change that into the square root of 36 times the square root of 2. But what is the square root of 36?
6.
Plain old 6 without a radical.
Oh, okay.
And what's the square root of 2? I don't know. It doesn't have a nice one. So we'll leave that as the square root of 2. And so that's another reason why I like to kind of separate it and give them each their own little party hats, so to speak, because then I can say, wait a minute, the square root of 36 is just 6. I took the root. It's out of jail, right? It doesn't have the radical around it anymore. Does that make sense?
Yep, thank you.
So let's try to find the square root of 125. Can either of you ladies think of a number that goes into 125 evenly? We'll go back to our list. 121 doesn't go in evenly. 100 doesn't. 81, no. 64, no. 49, no. 36, I don't think. I think I'd have a remainder. How about 25? Can I take 125 and divide it by 25?
Yep.
Yep. And you get that that's 25 times 5. So it's the square root of 25 times the square root of 5. The square root of 25 is just 5. And that other one, I can't take the square root of 5. I get an irrational number, a repeating decimal. Now let's try another one. Let's try to simplify. Let's say 4 times the square root of 18. What you have to remember is if that number's written right in front, that means 4 times the square root of 18. If they're written next to each other without a symbol in between. And so if I have 4 times the square root of 18, can anybody think of a number from our list of perfect squares that goes into 18 evenly? How can you factor 18? Well, one of the factors is a perfect square.
It's 3.
But 18 would be 3 times 6, but neither of them are perfect squares. Can we look at it as 9 times 2? And so
Why do
I'm
we
not
come
sure,
to 9 times 2?
because
do
we
we-
want one of those numbers has to be one of these perfect squares.
Okay.
We're always looking for one of these numbers that go in evenly.
Why couldn't we say 6 times 3? Because isn't 6 the perfect square?
Is 6 a perfect square? If I took the square root of 18 and I took the square root of 6 times 3, what number times itself gives me 6?
Okay.
Okay.
I guess because I was looking at it as it's
Even.
the 6 squared equals 36.
Yeah. No, we're looking for the square root.
Okay.
Okay. And so now we'll take the square root of 9 times the square root of 2. And because when you said 3, I was thinking you meant that the square root of 9 is 3. And I was thinking you were a step ahead of me. And now 4 times 3 is 12. So my answer would be 12 times the square root of 2. Final answer.
Okay, so we chose 9 because 3 times 3, that's a square.
Yeah, 9 is a square. It's 3 square.
But it couldn't be the 6 because even though that's a factor of 18, it's not the square of
It's
18.
not a perfect square, right?
Okay. A perfect square, okay.
So let's try a couple more. Let's try the square root of 44x to the 10th. Now our squares were 1, 4, 9, 16, 25, 36, 49, whoops, 64, 81, 100, 121, 144, 169, and that's where we kind of fizzled out. Which of these perfect square numbers goes into 44 evenly? Again, we're looking for the largest perfect square factor.
Four.
Beautiful. This pen and I are not friends anymore. If my hand touches the screen, it stops writing. So 44 would be 4 times 11 times x to the 10th, and that's even, so I can take its root. Now I'm going to split it up and give them each their own radical. The square root of 4 is 2.
2.
Square root of 11 I can't do. Nothing goes into 11 evenly. There's no number times itself that gives me 11. That's a rational number. And the square root of x to the 10 we said would be x to the 5. And now writing conventions, especially with people who have messy penmanship like me. Can you picture if you wrote that real fast, you wouldn't know if the x to the 5 was supposed to be under the radical or not? So it's most normal to write the radical last.
Can I ask you a quick question?
Sure.
Not extreme because I remember, but can you just remind me or refresh me, like to figure out what the square, to get that 4 of the 44 again?
What I would do is I would just look at this list of numbers and see which goes into 44 evenly. So the first one I try is 36. And if I divide 44 by 36, I'm going to get a remainder. If I divide 44 by 25, I'll get a remainder. I'll get a decimal, right? If I divide 44 by 16, I'll get a decimal. If I
Okay,
divide 44 by 9, I'll get a decimal. If I divide 44 by 4, bingo, that's my winner. I get a whole number.
okay. What goes into it evenly?
Right.
That's what I was forgetting. Okay.
Okay.
Yep.
So what if I do something crazy like the square root of 98? Try dividing. Which of these numbers can I divide 98 by evenly? Is it obvious we're not going to start with 100? If I take 98 and divide it by 81, think you're getting a decimal. What if I take 98 and divide it by 64? You got a decimal? What if I take 98 and divide it by 49? What do you get?
2.
2. So we'll think of that 98 as 49 times 2. Already all right with how we reached that executive decision?
Yep, because you can divide it, and there's no remainder. It's
Right.
even.
So we'll take the square root of 49 and multiply it by the square root of 2. And the square root of 49 is
7.
7. And the square root of 2 is the square root of 2. There's nothing I can do to make that number look pretty. Now let's try something interesting. Let's try something like, what if I have a variable in the radicand that's not a perfect square? And remember, if it's a perfect square, it's got an even exponent. An even exponent is a perfect square. So let's look at the square root of, let's say, x to the 5th. It's not an even exponent, so it's not a perfect square. So we're going to do with this variable expression the same thing we do with a number expression to simplify. We want to figure out what's the largest perfect square factor. And if it's an odd exponent, to find the largest perfect square factor, we're going to factor one of them out. Take one factor away. So what the hell does that mean? Well, I've got x to the 5th. The closest even number to 5, the closest perfect square to 5, would be x to the 4th. But I don't want to change what it equals, just what it looks like. So are you folks all right with saying x to the 5th is equal to x to the 4th times x to the 1st? And now I can simplify it. It'll be the square root of x to the 4th times the square root of x. And the square root of x to the 4th is x to the 2nd. And the square root of x is just the square root of x. Let's say I have the square root of, let's say I have 81 x to the 7th. Make a bigger radical here. I'm going to put all sorts of things in there. Is everybody all right? 81 is a perfect square. So I can leave that alone. X to the 7th, well, 7 is odd. The closest even is x to the 6th. And to keep it equal, we need one more x. So I'll take the square root of 81 times the square root of x to the 6th times the square root of x to the 1st, or x. And that'll leave me with 9x to the third times the square root of x. And so this would be my simplified answer. The first part of simplest form is that the radicand can't have any perfect square factors. Second part of simplest form, if I'm in simplest form,
And how come we wouldn't change that 9 to like 3?
because I've already taken the square root, you only
Oh.
do it once.
Oh, okay.
Simplest form, the second criteria is the radicand is not a fraction. And so here we're going to use that the square root of a over b is equal to the square root of a fraction is equal to the square root of the numerator over the square root of the denominator. So if I want something like the square root of 100 over x to the 8th, that violates all sorts of rules. One is that it's got a fraction underneath. So I'll change that to the square root of 100 over the square root of x to the 8th. Now can I simplify further? What's the square root of 100?
10.
And that's an even exponent. The square root of x to the 8th would be x to the 4th. Let's look at one more. Oh, this is an interesting one. I'm pulling this one out of a textbook. What if I have the square root of 23y to the third over 4x to the 6th? All sorts of things going on there. It's a fraction, so let's split it up. The square root of the numerator, over the square root of the denominator. But now we have to simplify the numerator. Can 23 be factored?
No.
No, so let's leave that. Y to the third, that's odd, so we'll change it into y to the second times y. So in the numerator, I'll have the square root of 23 times the square root of y squared times the square root of y. And let's see, I can't take the square root of 23, so that stays underneath. The square root of y squared is just plain old y. It goes outside. And that extra factor of y also has to stay underneath. Yeah. There's something on my touch screen and I'm trying to move it. And in trying to move it, I'm moving the screen around. I'm sorry. Now I've got to do the denominator. The square root of 4 x to the 6th, but we'll think of that as the square root of 4 times the square root of x to the 6th. The square root of 4 is 2. The square root of x to the 6th is x to the 3rd. And so this would be my final answer. So let's have you ladies try one. Let's look at the square root of 45 over 64. And I'm going to ask you to simplify that. Did anybody else get 3 radical 5 over 8?
Yep.
Yes.
Great, 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 great. So then,
I got stuck at the 9 times 5 for a few seconds, but then
you figured it out?
yep.
Good. Good. And there's one last thing that you need to be able to do in this section, and that's to approximate a square root and so let's say I want you to find let's say I want you to approximate to the nearest 3 decimal places. And let's say I have something like the square root of, oh, does anybody have a favorite number? No favorite numbers, ladies?
Oh,
Well, okay, then let's say the square root of 13. If I see round off words to the nearest, that's telling me that I'm going to use my calculator. So I'm going to take my calculator and let me clear it. Let me stand this thing up so that maybe you can see what I'm doing. I'm going to stop sharing for a second. Can you ladies, whoa, the sun is hitting me in such a way that you don't see much of what's going on here. Let me see if I move, well, maybe it'll work. Can you ladies turn your screens on and show me what calculators you have? Do you guys have the same one that I do? Or a similar one? Oh, is that a grapher?
I just have one on my phone that I guess I can change the,
Okay, now if you've got one on your
Themes.
phone, if you turn it sideways, it's scientific, right? So
Yes.
I think on your phone one, you can just hit a square root symbol. On one like mine, I don't have a square root symbol, but I have a symbol, a button for x squared, and written above the x squared button in fine print is a square root symbol. So I'm gonna, with mine, I press second x squared, and it opens up a square root of x. Lynette, does yours just have a square root button on it on your phone?
it does, yeah.
Okay, so you're just gonna hit that. Lynette, does yours have a square root button?
Yes, it does.
Okay, then you're just gonna hit the square root button and then type in your 13. Up,
Wait a minute.
and when you type in the square root of 13, I don't know about you, but I get 3.605551275 or something crazy like that. Are you folks getting something like that?
What'd you get?
3.607, I'm sorry, 3.605551275.
If I'm on my, I had to get the calculator on my laptop. Do I want standard or what's,
Why are you looking
Scientific.
for the one on your laptop?
my phone just died.
Scientific you want on the laptop.
Okay, thank you.
Lynette, did you get that?
No.
What did you get?
How do you type it in?
You're gonna press the square root button. Then you're gonna type in 13.
Wait a
And
minute.
then you're gonna hit equals.
So it's not 3.60555, that's the wrong way. I put 13 first and then the square root.
Okay, it depends on the brand of calculator. I think most calculators, you go first square root, then 13. But if you're doing that and you're not getting anything, then try first 13, then the square root.
And I did the square root. Oh, wait, sorry.
All right, I just got 1.01. Is that right? It keeps going on.
Um,
I'm not real familiar with this calculator, Chris.
okay, what I want you to do is clear everything out,
Okay.
press the square root button. Then
Okay.
just type in the number 13,
Okay.
then hit the equal sign. What are you getting?
Wait a minute.
I can do it right on my phone, but I think the only thing I'm seeing on my computer is I've chose scientific,
Uh-huh.
then it's got rad, and then it's got trigonometry and then function. But it only shows me a square root that says 2 on the outside with that
That's
symbol and then
what you need.
X.
Yep.
Okay,
That's
so
what I just got. 2.036818,346.
For the square root of 13?
Yes.
Okay, I'm gonna go, oops. Lynette,
Yes.
let me change this to speaker view. And can you hold up your calculator again?
Wait a minute.
See,
Can you see it? You're really dark.
yeah,
Everything's dark, the whole screen.
yeah, the sun is shining
So
on
it's a square root, the X symbol, and then the 2, or the X in a little box?
The square root symbol should just look like the radical, the check mark shape.
Oh, wait a
yeah,
minute.
by itself, yeah.
by
I don't,
itself.
yeah, I'm just not seeing that on.
Oh, I'm hitting the
okay.
wrong button. Yeah, I just bought this calculator a couple months ago on Amazon.
It was probably more expensive than it needed to be.
Probably.
Yeah. I'm thinking the one in my hand I got for under $10.
Oh, wait a minute. I think I see it. Okay, so I type in 13 and then the symbol.
Yeah, try that 13, then the symbol, then hit equals. I think it's got to go the other way. I think it's got to go first the symbol, then the 13.
All right, then I got the symbol 13.
Yeah, and then press equals.
Symbol 13.
Oh, with the equals, it gives you, it doesn't change it into a decimal.
Wait a minute. No.
Okay, then that's got to do with the mode of your calculator. Is there a button you can press that says mode on it?
No.
No.
No, I go to the second and then I can get these other ones down here.
I can't see your calculator. You're not holding it in front of the camera.
Can you see it now?
Yeah, I can see it. And so,
Mhm.
what's the button? What's the first button next to the second button say?
Oh, mode.
Press mode.
Yes. You gotta excuse me, Chris. I'm just not used to this calculator at all.
That's perfectly fine. Oh my gosh, the first time I had to teach a class with a graphing calculator, it was when I was coming back to work after being a stay-at-home mom for 5 years. And I went from kids can't use calculators in class to here's a graphing calculator, teach with it. And I didn't know how to use anything on it. And so it was a nightmare for me. So I totally understand where you are. When you
Okay.
press that mode button, what are the choices? What does your screen say after you just press the mode button?
It says DEG, rad, grad, Nora Psi, English, or something. Here,
Okay.
look at that.
Yeah.
Can you see it?
What I want you to do is oh, it is in normal mode. Arrow down so that Nora is highlighted and
Waiting.
arrow over to Psi.
Okay,
No, actually arrow over to English.
okay.
Then hit enter. Now try the square root symbol 13 equals.
Wait, now I can't get out of this mode.
Quit. There should be a button somewhere that says quit.
Okay, now what do you want me to do?
Press the square root symbol,
Uh-huh,
then the 13,
uh-huh.
then the equals.
Okay,
And
I
what do you
got
get?
169 E0.
Okay, no, that's not it. That squared it. Is the square root symbol right on the button, or is it written above the button?
It's written above. I think it's in the second mode.
Okay, so let's go back. Let's go back to mode. Go down to norm, hit norm,
Okay,
then quit that screen. Then go second and hit whatever button the square root symbol is above.
uh-huh,
Then hit 13,
uh-huh.
then hit our equals.
I'm getting square root of 13.
It doesn't give it to you as a decimal.
No,
On my phone, though, I got to back up. I either have the choice of rad or degree. And so I chose rad and I got 3.60555512.
Yeah, The rad or
Is that correct?
degree has to do with angles. Your phone should give it to you without changing the mode. You get the
Okay.
3.6.
should I go on my phone?
Sure.
All right, hang on a second.
Lynette, what type of calculator is that?
Texas, it's Instruments.
And is there a number to it? TI what?
36X Pro.
Okay, I'm looking up the manual now.
Yeah, I think it's too complex for me at this stage of the game.
No.
Hang
I
on a
don't think
second,
so.
Chris.
Not to get off topic, but how's the
Yeah.
grandbaby?
Oh, I'm gonna show off that you asked. They sent us pictures yesterday, and is that the cutest thing? Can you see him?
Oh my God. Yeah, look at that hat.
Little hat and the little sweater.
So cute.
And then the other one, they're having such a hard time because I think he's colicky. He just, if they're not holding him, he won't sleep. And if they're not holding him, all he does is scream.
Oh,
And even when they're holding him, if he's not eating or sleeping, he's screaming.
oh.
Yeah, I remember one of mine being somewhat like that, but not quite as bad. But actually, his father was my crankiest baby, and
Uh-oh.
if he was awake, he had to be held. But I think the problem is now they say that you can't lay babies on their bellies; you can only lay them on their back. And I think he doesn't want to lay on his back. So if they lay him on his back, he immediately wakes up and starts screaming. So the poor guy.
Okay, I just
Nursing.
did it on my phone,
Uh-huh.
and the answer is 3.60.
Beautiful.
Okay.
Okay.
Get the calculator. I'll just use my phone.
Okay. So go up. So I got to go back and share my screen again, right? It doesn't do
Okay.
any good if I change it without hitting share screen first. So over here to the nearest third decimal point, is everybody all right? That would be 3.606. I have to round up because the next door neighbor is 5 or higher. Are you guys all right with the 5 up rule?
Yes.
Okay. Now, another thing, just to give you an idea of where your answer should fall for approximation purposes, we have that list. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Are you ladies all right that because my number 13 was somewhere between 9 and 16, it told me that my square root should be a number somewhere between 3 and 4? Does that make sense?
Mhm.
Yeah.
So let's find the square root of, let's say 27. And now before I put it in my calculator, are you guys all right? 27's a little bit bigger than 25. So I know it's going to be, my answer should be 5 point something. Before I type it in, does that make sense? And is anybody else getting 5.196?
Yep.
Great.
Yes.
Okay. Okay. Lynette, I found the answer to your calculator.
Okay.
I'm reading the
Let's get
manual.
that out.
You got it?
Yes.
Okay. So hit that mode button.
Okay.
You see degree, you see
Yes.
norm, you see float,
Right.
you see real, arrow down, you see DEC, arrow down again, you see classic and math print.
Yes.
Hit enter when your cursor's on the classic, because right now math print is highlighted. We don't want math print highlighted. We want classic highlighted.
Okay. It's highlighted.
Okay, now quit.
Quit.
Now take the square root of 27.
See, when I hit quit, I'm back at degree, that mode.
Okay,
So I just need to clear it, right?
yeah, you can clear it.
Okay.
Now take the square root of 27. So second square root 27.
Second. 27.
Did you get the 5.196?
Yes. Oh my
Yes.
God. Thank you so much.
I knew that it was in the mode. I knew it was a math mode, but I didn't see it on that first screen. But I
Right.
opened up the manual and realized that the reason it wasn't on the first screen was because we had to scroll down.
Uh-huh. Okay. Thank
Okay.
you. Now I can use it.
Hey, you know what? Should I give you a cheater's way?
Sure.
If you go back into that math print, the calculator should be able to simplify a radical for you.
Oh, okay.
Okay?
Uh-huh. Thank you.
But that's
Yeah, I just have to get used to this.
right,
It's all.
right. So, and I apologize. I was looking up the manual as we were talking. So, what do you ladies think of these radical things?
More
Not
practice.
completely
Okay.
difficult.
Well, I'll tell you what, all we have left to do now for the rest of the semester is practice what you need to practice, go over what you still have questions on, finish the homework and take 2 tests. In terms of new material, we're done.
Okay.
So
Thank God.
my schedule for me for the rest of the semester is on one day, I'd like to go over that problem set 5 with you, so you're ready for exam 5. On one day, I'd like to go over that practice final for you, that preliminary final, so you're ready for the final. But otherwise, class time, the only thing that's on my agenda is to go over whatever you guys want me to go over. Whatever from the beginning of the semester on you feel you need more practice with, you feel you have questions on, you feel you have the need for more of an explanation. Okay,
Okay.
so I'm giving you homework in addition to the homework, and that homework is to look and see what you need more clarification on, what you need more explanation on, what you need more help with. Skim over the back homeworks. What was super challenging for you that you'd like help going over again? Okay?
So that's what I was going to ask you. Like, what do you think is, what if I was going to use a tutor resource here for, I think the only thing I really hate is like, I'm not fully proficient at that if I just got set loose on my own to solve my way or you'll kill me, like linear equations, I think just,
Okay. Then go into that linear equation homework. And honestly, you've got the homework done, you've got a grade on it. You can still go back and click on that homework and do it over and over and over again. It's going to keep that best grade. So if you need more practice, or if you want more practice with that line stuff, that linear stuff in general, go to that linear test. You should be able to review it. That linear problem set, you should be able to review it. Do those
okay,
over
that's
again.
good.
And
The
I'll tell you
problem
what,
sets.
we will remind me of this conversation, and we will review everything to do with lines after we go over the practice test first. Okay?
Okay. And then, so could I do the preliminary final? Is that something I could use as practice or not? Can you not
Yes.
use that?
You can do that an infinite number of times.
Okay, that's
I
like the
think
problem sets.
Yeah, yes. You can do it as many times as you want. And again, the more often you do it, the more comfortable you are. Okay?
So that would be good to do. Okay.
Right. Lynette, is there anything in particular that you feel the need to practice more on?
Just everything in general. I'm just gonna finish off the homework and then just start reviewing, Chris.
Oh.
So
Oh.
if anything comes up, I'll definitely email you.
Yes, and make a list as you start going over things of things you want more of an explanation of in class. Because that's all we're going to do from this point on, is help you ladies review with what you need to. And not just you ladies, whoever else shows up for class.
Right.
So if I come across any problems, maybe I could just write them and like, then I could maybe scan them in and just send them to you like in one shot so that I could say, hey, I couldn't remember how to do this on my own. Like, can you refresh my memory?
Sure.
Okay.
Or if it's in, if you're doing it in my labs, there's that help my instructor button that just sends me the question.
Oh, okay.
Okay?
Yep.
Ask my instructor button so that you don't even have to write it down and scan it in.
Oh, okay.
Okay?
And then you'd write it back to me?
Yep.
With the work? Okay.
And it probably isn't more meaningful for you if I write it back on a touch screen and send a handwritten document instead of trying to type words out.
Yes, yes, yep.
Okay, so from now on, I will do that because I realized I got this new phone.
I mean, if it's not more work for you, but that
No,
helps me.
it's easier to write math than it is to type it.
Okay.
So we'll do it that way. Okay?
Yep.
All right, then shall we call it a class for today?
Yep.
Sure.
Okay, let me stop sharing my screen. Let me stop recording.